Hello everyone, we are getting started with the second week lab experiment for creating an alcohol. Currently, you see the TA has a round bottom flask that has all of these needles in it. This is actually showing that at the point that they're at right now in the video, they've already done steps 1, 2, and 3 for week 2, which is warm a beaker of water to about 35 degrees C. The previous week's solution. They poured it into that 25, which is now empty, but that 25 milliliter round bottom flask. They heated it in the water bath for 5 minutes. Then they added about 1.5 milliliters of 3 molar sodium hydroxide. And then they also added 2 milliliters of 30% hydrogen peroxide. And then where they added it dropwise. The 2 milliliters was added dropwise. And so they continued to heat for 30 minutes, and then they got this slightly yellow tinted looking solution. And so now they're at the point where they're about to add 5 grams of potassium carbonate. And this potassium carbonate is very important because right now, since they have already added the previous, remember at the end of week 1, in step 11 of week 1, their final product that they got, that they put in a vial, it had solution and solid. The solid was a sodium boroxide type sodium boroxide product. That was that white solid stuff that you saw. And then the solution was your hexene, where you no longer had the pi bond, so it was like a hexane chain attached to a boron. And so that's why adding the base, sodium hydroxide, and the hydrogen peroxide are important here, because now they do have alcohol, like so hexanol, 1-hexanol in that solution. And then it being an alcohol, it can hydrogen bond, so it does have some solubility in water, but since it also has a 6-carbon chain, it's also quite soluble in an organic layer. So by adding the potassium carbonate, they what's called salt the aqueous layer, making it highly ionic, and that makes the alcohol less soluble in water. So now when they get ready to do their extraction with hexane, that alcohol is going to prefer an organic phase, hexane, over the aqueous phase. And so right now you can see that they are vigorously shaking it. Shake it like a Polaroid picture. But you can see now they're shaking, or they're finished. They shook the potassium carbonate until it was completely dissolved. And so now you can see that they're getting the hexane bottle. Pointy point point. There it is. All right. Yeah, look at that pretty pink little label. All right, and so what they're going to do, they're going to take 6 milliliters of the hexane right now, and they're adding it to the Erlenmeyer flask. And they're shaking, shaking, shaking. Right, you want to do some shaking so that you can try and get those two phases, the aqueous and organic layer, intermingling, and have some of that alcohol go into the hexane layer. And so there are 2 layers. Right? There's a bottom layer and the top layer, and the top layer. And so remember, you're looking at hexane and, well, here, let's pour it in the separatory funnel. It'll be easier to see. When we look here, you do have 2 layers. So you have a clear layer and you have a yellow layer. Of those 2 layers, that yellow layer should be your organic layer, hexane, because remember, when we talk about 2 different layers, especially now that we have an aqueous layer and an organic layer, 9 times out of 10, not always, but 9 times out of 10, your organic layer is less dense, so it tends to be on the top. One of the 2 big exceptions to that are if you ever have to use organic solvents like DMSO or dichloromethane. Those 2 tend to be heavier than water, or more dense than water. All right, so anyway, so they removed the aqueous layer, and so now all they have is the yellow-ish organic layer that's got the alcohol in it. And so now they're adding 7 milliliters of 30% sodium thiosulfate. All right, and so what you'll see is a lot of the yellow color will leave. All right, and so with this sodium thiosulfate, you're going to see. Now remember, in the reaction we did. Ooh, look at that, so pretty. All right. All right, and so upon adding it, right, you no longer see any yellow whatsoever. Okay. All right, and yet again, you have an organic and an aqueous layer. So that bottom layer is going to be your aqueous layer. So they're going to remove that, as they're doing right now. Okay, now they're going to do a second wash to kind of clean up the organic layer as much as possible. They're going to have a brine solution or a saturated sodium chloride solution. They're going to add about 8 milliliters of that to the separatory funnel. There we go. And yet again, you got two layers. You're going to have an organic and an aqueous layer. And so the brine solution or the sodium chloride solution is going to be on bottom again. All right, there, shake, shake, shake. Shake that separatory funnel, and they vented it, and they're putting it back. All right, now they're going to remove the aqueous layer yet again. All right, and then as one last precautionary measure, you could still have some water in the organic layer, and so as a means to remove that water, they're going to use an anhydrous solid, sodium sulfate, which is very hygroscopic, so it's going to absorb water quite readily. All right, and so they're going to put it in the Erlenmeyer flask that has the organic phase. All right, and then shake it a little bit and let it sit for about 15 minutes to absorb all that water. And so now they're decanting the remaining solution, which should just have hexane and your alcohol. All right. Now remember, this anhydrous sodium sulfate was very, very important to remove the water, because you are going to be looking at your alcohol product in IR, and so water and alcohols both have OHs, right? So you want to know you got one over the other. Okay. All right, and so now that it's dried with water, they're using the rotovap. Okay, so that they're going to get all the hexane off, and what you the big thing here, most of the time in the rotovap, whenever you are trying to take solvent off using the rotovap, ooh, that's too fast, slow that down. Hey, hey, hey. Oh, there we go. All right, so what you're going to see here, your remaining product, the alcohol, is actually going to be a solution as well. And the one thing to also be aware of, it's not gonna be easy to see. So, but do be aware of that. So they're trying to kind of show it to you. There's a teeny tiny little volume in there. All right, that little bitty amount is your alcohol. All right, and so at this point they're weighing this is the rotovap round bottom flask with the alcohol in it. So 71.61 is the mass here. And then at the end of it, they're going to show you what the mass of the empty round bottom flask is as well. All right, and so taking IR, this right here is a background spectra for IR, so a blank, right? All they had was, they had nothing in it, and they took the spectra. And so now they're going to add the alcohol right there. They're going to close the needle on top of it so it doesn't evaporate. and acquire the IR spectra. So the big thing here is if you're seeing an alcohol, you should see a broad band. Oh, there it is, a broad band somewhere around 3300. Okay. And if you notice after the 3000 range, there were no bands, no sharp bands. So that alkene band, the C double C single bond H band, is not visible anymore. So you did convert all of your alkene to the alcohol, or you at least separated all the alkene from the alcohol uh, if you didn't do a 100% conversion. All right.